Okay, so today I'm gonna explain you how our homes actually get the electricity. How do we receive the 220 volts and 50 hertz and all craps of electricity at our homes, at our mains. So basically, I ought to think that initially, if we had simply a battery or a power source and we directly connect an LED or something, then we just get the output, and there is no other terms of hertz and AC, DC, and anything. So basically, there is actually. So we don't simply get the electricity that is generated by the generators directly to our homes. So how do we actually receive the current? So basically, um, we have our power lines, and there is generator here, say generator, that is generating the electricity from, say, different sources of energy like wind, or maybe water, or maybe nuclear power, or thermal power, or something else. So all these help in generating the electricity. Now, why is alternating current generated? This is because these all sources actually remove a turbine, and this turbine is connected to a magnet. These magnets, according to Faraday's law, these magnets revolve and induce the EMF into a coil. As we know that moving or moving magnetic flux generates a electric current. So this is how electric current is generated. But the fault is that we actually can't have a continuous system, or maybe we don't have a continuous coil, because at some point we have to end the coil. Okay, in a continuous coil, how can we have a current in our practical case? So that's why there is not just a V naught generated, but a crap with it, that is sine omega t, and this is what makes it alternating. V naught sine omega t, and this is called the alternating voltage because this is varying with time, and this omega is the angle, the phase frequency. Now, I'll not go into the depth of alternating current, but I'll show you how this is transported to our homes. First of all, this V naught is the main voltage, or something that is maintaining the magnitude of the uh, voltage that is generated. So this is actually high voltage that is generated over here, around some 5,000, or depending on the source of electricity. So that is too high for our homes, and we actually can't uh, afford to uh, give that to homes because that's too dangerous. So how do we control that? First of all, these power lines are now going into a power manager. Power manager is basically something that can reduce the magnitude of electricity that's going. How can we reduce this? Now I'll introduce the concept of transformers. Well, transformers are of different types. There are potential transformers, current transformers, or many others, that is phase transformer and all. But I'll just explain you the simple concept of transformers. Basically, transformer is a magnetic core. I'll just make a wicked magnetic core. Okay, so magnetic core, and this magnetic core has coils around it, coils around and on. So say this and this. So basically, this is called the primary coil, and this is the secondary coil. These coils, what do these do actually? First of all, I am applying this generated current, generated EMF through this coil, and this is inducing another uh, current into this coil, which is uh, which is actually going to our homes. So how does this change the magnitude or change the current and voltage? How does it do that? So if we are putting a number of coils here, say N1, if we are putting N1 number of coils here and N2 number of turns actually, number of turns here. Um, if we have more number of turns here and less number of turns here, we will get a less voltage, because you can see that if we have more coils, we will have to shorten the thickness of the wire, and here in the on the other